Good afternoon and good morning to those of you out west. Welcome to today's webinar from Metal Architecture Magazine and Steelscape. My name is Stacy Ranella. I'm the editor-in-chief for Metal Architecture, and I'll be moderating today's presentation. Just to cover a few housekeeping items before we get started, if you have any questions during today's webinar, please enter them using the Q&A section, which you can find at the bottom of your Zoom window. We will address as many questions as possible during and at the end of the presentation. Zoom does have a raise hand function, but since we'll be keeping everyone's mics muted, only use the Q&A instead. If you're experiencing any technical difficulties during the webinar, you can enter a message in the chat, which you'll find right next to the Q&A, and we'll do our best to help. Today's webinar is being recorded and will be available on Metal Architecture's website by this time next week. Now I'd like to introduce our speaker, Michelle Vondran. Michelle is the Manager of Product Innovation and Technology at BlueScope Coated Products North America. Michelle graduated from California Polytechnic State University with a degree in chemistry. She started her career as a research chemist with Morton Coil Coatings with a focus on polymers. This position also included lab development as well as lab to production scale-up and manufacturing quality and process control. Eventually, Michelle's focus shifted to cool pigmentation, where she brought the first cool coil coatings to market. She was active in the Cool Roof Rating Council and Energy Star roofing program. She joined Steelscape as a quality engineer for the Rancho Cucamonga paint line. As technical manager, Michelle oversees quality systems and technical services for BlueScope Coated Products North America, which is comprised of Steelscape and ASC profiles. Michelle is the active member of the National Coil Coaters Association, sitting on the technical committee, as well as the Zinc Aluminum Coaters Association. In this webinar, Michelle will discuss pre-painted metal. Michelle, we appreciate you joining us today. Please take it away.
Thank you, Stacy. Welcome, everyone. I hope everyone's having a good day. I always like to start by promising everyone on the call that we're not going to do any hard chemistry or science today, so I don't want to scare anyone with my background. So we'll jump right in. Understanding pre-painted metal today. Some, administrative stuff there, contact information. We've broken this into 4 sections. We're going to talk about the fundamentals of pre-painted metal, the application process, how we make the material, the advantages of that and why we do it the way we do. And then we'll dig into paint systems in a bit more detail. Third section will be enhancements or specialty paints that are available and when and how we want to use those. And then we'll finish up with pre-painted metal durability, long-term performance, and warranty considerations. So what is pre-painted metal? This is a very easy definition because it's quite self-explanatory. So we take giant rolls of usually steel or aluminum, but it can be other metals as well. Apply the paint in a continuous fashion and a continuous line in a factory. That all happens before that metal is then formed and made into its final pieces and parts, roof panels, wall panels, whatever the end use might be. Our focus today, of course, will be on exterior architectural type panels for roof and wall. Not all pre-painted metal is the same. The paint plays a huge part in the performance and the look you're going to get, and that's kind of where we're going to focus today. However, this pre-painted metal, or the coil coating world as we call it, is used for a lot of other applications besides building products. We've got some listed here. Exterior building products, pretty self-explanatory: metal roofing, standing seam, light commercial, gutters and rainwater goods, trim, insulated panels. But we also use the same process to do HVAC, appliances, cabinetry, hot water heaters, door trims, window trims, a lot of interior products, metal filing cabinets, a big user of this as well. So our first question: how is paint applied to metal for the majority of building applications? We've got 4 primary modes of doing this: airbrush, dipping, rolling, or brushing. This process today we're going to talk about is a rolling process, but not like rolling on house paint. So pre-painted metal or coil coating is a method of applying paint to metal in a continuous fashion in a factory environment. It's continuous. We clean the metal first. Goes through a set of cleaners. We put pre-treatment on, then we apply primer and paint. We bake this at very high speed. So most of these lines run anywhere from 100 up to 700 feet per minute. And we can apply paint and cure it to a finished dry state in 15 to 30 seconds. This is a very generic schematic of what one of these paint lines or coil lines looks like here. They do vary a bit from manufacturer to manufacturer, but they all have the same pieces and parts. Our lines here at Steelscape hold about 2,500 linear feet of metal from end to end. So they're quite large, usually multiple stories high as well. Those accumulator towers that you see there are anywhere from 4 to 8 stories high, depending on the size of the line. The speed is incredible, much, much faster than any other industrial coating to metal process that's out there. Current technology, a whole car takes about 30 minutes to 2 hours to coat. We can coat enough metal in 15 minutes to make multiple buildings and roofs out of. So very different scale. It's also the thinnest coating applied in the industrial coatings world. We're applying this coating at about 0.0014 inches, which is thinner than paper, and expecting it to then go through the forming process and also hold up long-term on the outside of a building. So like I said, we clean the surface thoroughly through a set of cleaners and or brush units so we can get a really good bond on the paint. It's a very tightly controlled process. So the strip is moving, and we move these big rolls that you see there into the strip rather than moving the roller on the surface like in most traditional painting applications. Our top coats, along with primer, are about 0.7 to 1.0 mils in thickness. So again, very, very thin. Other industrial coatings are 2 to 5 times that in thickness. And all this done again before fabrication. So this paint has to be both hard and also flexible at the same time, so it can make finished parts. So there's a lot of science and research that goes into that. These are closed loop systems. We are using solvent-based paints, but all of these paint lines are capturing those fumes and incinerating them, actually generating heat through a thermal oxidizer to pump fuel and energy back into the line. So the final product is zero VOC. Now, the speed of which we do this and the size of it, and here's a picture of a line here, you can see the scope of it, does come with some limitations. It's very rapid. We like to set up and do long runs. We don't like to change colors out very frequently. It's very difficult to do very small runs of metal. It's just not efficient or economical. So you get a little bit of a restriction in the color palette, but not much. There's still, right now in our company, I think we have about 40,000 specific paint colors and codes on file. So it's not terribly restricted. But if you want to do very small runs of custom colors, that, is probably going to have some extra lead time and costs associated with it in the coil coating world. Again, a lot of tightly controlled quality and specifications that go into this, right? We're applying this very, very thin paint very, very quickly, and we know that it's got to go through extreme forming after it leaves the coil line. So we do bend tests and impact tests to make sure that it's going to adhere and bend and flex the way it needs to. We do color validation, hugely important in the architectural space, right? The color needs to be consistent across the width of the metal, from end to end of the coil, from coil to coil, and from production run to production run of the same color. Very large projects may require 3 or 4 big runs of coated metal off of one of our lines. It's all going on the same project. It's going to have to match. So we control almost all of those, probably 90% of our colors numerically with color computers very tightly. The gloss, right, how kind of shiny or reflective it is. And of course, the film thickness is critical not only to the forming process, but for long-term wardability and performance out in the field as well. I mean, keep in mind that this product is going to go out on the outside of a building, and we're talking about, for high-end paint systems, warranties from 25 to 40 years that this product has to perform, exposed to the elements that entire time. By contrast, everyone always likes to compare our product to the automotive world. The average car paint warranty is only about 7 to 10 years. And cars typically are often under shelter or garage. They get washed regularly, right? They get very well taken care of. There's maintenance done on them. Not so much with our buildings. And these paints are outperforming what cars do. Before we dive into paint and the paint layers a bit more, I do want to talk a little bit about the substrate underneath. So today we're talking about metallic coated steel primarily, but also aluminum. Obviously, we coat steel because in and of itself it rusts, has no corrosion protection. So we apply either zinc or a zinc aluminum alloy to get long-term corrosion performance. It's the most widely used products in the building industry. You may be familiar with the trade name Galvalume or zincalume for the aluminum zinc product. That is a warranted product for corrosion, whereas galvanized is not. We have a whole nother AIA presentation on this substrate if anyone's interested. That aluminum component is about 55%. That's an optimal ratio. Is a licensed technology as well that's out there. There's 8 producers of that in the US right now. So this is also a very large continuous line that we put these metallic coatings on the steel strip. They run about, again, 200 to 500 feet per minute. They're much larger than our paint lines. These metallic coating lines hold about 5,000 linear feet of steel from end to end, so they're very large. Again, Galvalume, if you see the name Galvalume or zincalume, that is a licensed technology. There's a website where you can check them. There are producers making an aluminum zinc product out there who are not licensed. They are forbidden from using those trade names in the market. Okay, paint. What is paint? Well, I went too far. Yes, where's my previous? We all know what paint is, right? We've all dealt with paint. Whether it was finger painting in elementary school or painting your inside of your house or whatever that might be, we've got experience. It's a liquid. You put it on a surface, it's going to dry to a solid. It needs to protect that surface. And more importantly, we usually want it to look a very specific way for design purposes, aesthetics purposes. In our world, for pre-painted metal, these components of paint break down into kind of 4 categories. You've got the resin or the polymer. That's the binder of the paint. It's going to determine most of the physical and chemical properties of that paint system. We have the pigments, obviously hugely important as well. They impart the color and the aesthetic attributes to the system. The solvents, I talked about that these are solvent-based paints. They have to be in a liquid state so that those of us who are doing the painting can actually get it on the strip. Got to be able to pump it out of a drum, put it on those giant rolls in a consistent fashion. And then there's various additives put into these formulas, to help with kind of niche specialty performance criteria that's needed or desired. Kind of a cheat sheet. What these things are bringing to the table. The polymer or the resin here is shouldering the bulk of the workload, then pigment, then solvent. This is kind of a typical breakdown by weight. 30% will be the resin, 30% is solvent. That all goes away in the final product, 35% pigment, and then a little tiny bit of additives. Some formulas don't have any additives at all. So how do you know what paint you want? Well, it's very much dependent on the end use. For the building segment, exterior panels, you need something that's going to be able to be roll formed into a panel, but is also going to, perform long-term out in the environment. Going to have some hardness to it too, right? You don't want it to scratch easily. It's got to be handled and installed. It gets handled kind of roughly. It's being pulled out of, off the trucks and out of packaging and thrown up on a building. So for the building world, we tend to err to the side of harder, sacrificing a little bit of flexibility, but it's a very delicate balancing act. And, one panel manufacturer may need something different than the guy down the street, even though they're making a similar type of product based on their tooling. So these paints are all customized for that. And then, of course, cost, warranty becomes a factor as well. Pigments and color are the fun part, right? These are insoluble solid products, finely ground and dispersed into the resin. You have to You want your pigment particles to be as small and fine as possible. That's going to give you color stability and long-term performance. And you want it to, quote, wet out or attach to that resin or polymer as evenly as best as possible. We use a couple different classes of pigments. We have organic and inorganic. Inorganic pigments is primarily what gets used in our industry. These are metal oxides, things mined out of the earth. They're a little bit duller in color, kind of your yellows, greens, browns, reds that are mid-tones, not very crisp or clear. We do have organic pigments as well. These are your bright primary colors. They tend not to hold up very well to UV, right? I think all of us at some point in our lives, you see the faded red cars and faded red signs. Those bright colors just don't do well in the sunlight long term. So we try to steer clear of those as much as possible, but we can use them in small percentages without any takeaway from warranty or performance. The application of color, I talked about our color control, very, very important as well. Right, how does the eye see color? We can do that numerically on computers for most colors. We can't for the sparkly micas and metallic coatings. We can't use color equipment, but for everything else we can. We measure an LAB value, that's light, dark, you know, green, blue, red. Every single time we go up on an order, we are controlling that color to a, quote, master standard that's stored in the computer and making sure that the deviation is very small. The human eye doesn't start to pick up color difference until you approach what we call a delta E, or a color shift of 1 unit. We are controlling to 0.5 or less in production most of the time. So the untrained eye, even the trained eye, is going to have a very difficult time seeing a difference in color. We have several layers of paint that go into this product. Schematic here, the metal in the center, and then we've got pre-treatment that we put down, right? That's just to help prep the surface for the paint and get good adhesion. Then we put a primer down. The primer is there really to provide stability for the top coat. It's also bringing a lot of corrosion protection to this product as well. And then we do the top coat. We do apply paint on the bottom side, even if it's not going to show. That's, again, the same primer that's on the top. And then we have a backer coat or a wash coat on the back side, which is usually an off-white or a light gray. That is to help with corrosion protection as well. It's also to help when you roll these rolls of metal back up on themselves after they're painted. If one side is not coated, it can damage the painted side that it's in contact with, because the tension is very, very high in these coils when they're wound. So there's a lot of pressure occurring in that roll. So you want to make sure that paint surface is protected. We do have clear coats and some other stuff. We'll talk about that a little bit later in another section that we can add as well. Almost every paint line can coat full color coat on both sides if it's desired. There's a lot of instances where both sides are going to be seen in the final installation. It can actually be different colors. We can paint one color on the one side, one color on the other side. Doesn't have to match. Not a problem. Okay, I'm going to pause there real quick for any questions before we jump into paint systems.
Thank you, Michelle. That's great stuff. Quickly, I just want to add, if anybody is requiring a certificate, it typically takes up to 5 business days. So just keep checking your email, your junk folder and your spam folder, just in case it goes in there. We have some great questions coming in. First question, is there any fading, etc., added to the coating process?
The fading. I'm sure I understand the question. To prevent fading, or are they asking if there will be fading of the system over time? To prevent fading. Yeah, so to prevent the fading, a lot of that comes from the pigmentation selection. So these high-end inorganic pigments have been heat treated to be incredibly stable in high UV conditions. So yes, and then there are also, one of the additives that gets used a lot is actually transparent to the eye, UV blockers. It's like sunscreen for paint. So there are UV blockers that they put in these paint systems as well to protect the polymer and the resin from breaking down in sunlight.
Okay, next question is a two-parter. Primary components of paint slide. What is the modeled finish called? How is it done? Also, is there a three-part CSI specs or master spec available for specifying that modeled finish?
Yeah, I'm not an expert on those CSI specs, but yes, there's a lot of specs out there for the paint systems that will detail what each of those layers needs to be and the thickness they need to be. Yeah, I know that those exist out there. So there are specs that will call out the primer and specifically how much primer. They'll call out the color coat and how much of that. They may call out the clear coat as well. So that does happen. Lots of different specs. You can run these paints in a lot of different configurations.
Okay, we'll take one more question. Clients are starting to request dark grays and blacks. Are
Yep.
these more UV stable than they were, say, 5 years ago?
Yeah, huge trend, right? I can't believe how much black we run these days. I never would have thought it 25 years ago when I entered this business. But yeah, I would say that yes, pigment technology and polymer technology continues to evolve and improve. And yes, I would say that they are better than maybe not 5 years ago, but certainly better than they were 15, 20 years ago. I mean, almost everyone has shifted to really good, durable, inorganic black pigmentation and improve their polymer and resin structures as well to help with that UV breakdown. So, but darker colors, regardless of all that, are still going to show more fade over time than lighter colors, right? There's just not much we can do about that. But yes, I think fade in general, not just for blacks and darker colors, but for all colors in the last 15, 20 years has improved.
Okay, let's get back to your presentation, Michelle.
Okay. Common paint systems and their differences. So what are the three most common systems we use in building applications? Polyester, silicone modified polyester, and fluorocarbon or PVDF, which also goes by a whole lot of other names, which we'll get to. But these are the three for exterior building applications, the focus today, that we see the most. Polyesters are great, right? Polyesters are really great workhorse. They've been around a very long time. This is very old technology. Silicone modified polyesters are exactly what they sound. They take a polyester, they put some silicone in it, makes it a little bit better, got a new paint system. And then the fluorocarbons or PVDF, you may know it as Kynar 500 or Hylar 5000. You see that in the architectural spec a lot, licensed technology. Polyvinylidene fluoride, there's a little bit of chemistry for you, is the technical name for it. I don't know why as an industry we can't decide on one name for this product. I think we like to confuse everyone, but it does go by all these different nomenclature, unfortunately. These are sort of sitting here in range from good to best, and we'll get into why that is. So the polyesters, very cost effective, really great flexibility, but also good hardness, wide range of colors and glosses available, incredibly versatile chemistry and paint system. I like to remind people here when we're talking about polyester, and polyester is a type of chemical atomic structure. So it's a huge class of products. I mean, think about some of you are most likely wearing clothing that is polyester clothing. That is the same basic chemistry of what we're making these paints out of. So crazy class of polymers that you can do just about anything with. We see polyesters these days, their long-term performance is good. It's not the best. We see it for lower end metal roofing, gutters, downspouts, light agricultural and commercial. Polyesters are also what you're going to see for interior products because it doesn't need to have that long-term performance outside. So appliance wrappers, door frames, window frames, T-bar in the ceilings of buildings, these kind of things will be polyester technology usually. Silicone modified polyesters, we step up. You actually react some silicone into that backbone of that resin. When you do that, you get kind of a big step up in weatherability. Get much more improved resistance to shock and fade in the outside world. Still get a huge range of colors and glosses available. It's a lower cost than the PVDF or the fluorocarbon products. So it's kind of a nice price point. See this a lot for commercial and especially residential sidewall and roof applications. These products have very good warranties, 25, 30 years plus, depending on the supplier. So they're going to hold up very well. Here's a lovely either black or very dark brown roof. We just talked about the, trend to darker colors. Nice example of it. This is a really good workhorse product. And I would say I've been doing this a very long time. I'm not going to give out years, but I've been around a long time now. The performance of polyesters and silicone modified polyesters has just gone forward by leaps and bounds since I started in this industry. So it's the gap in performance between all of these has shrunk tremendously in the last 15, 20 years. Leading us to fluorocarbons. This is the Cadillac of them all. This is the granddaddy, the big kahuna of the pre-painted metal world. It is by far the most resistive product we have available right now to chalk and fade, aggressive weather elements, highly resistant to chemical degradation as well, has excellent formability. This is what you're going to see specified and called out in the Corps of Engineering specs. High-end commercial buildings as well, although we use it in residential quite a bit. Is it an expensive product? Yes, but you kind of get what you're paying for. Has the longest, most robust warranties out there in the market right now. And you can do a lot with it. So if you have a highly, and we're going to talk a little bit about enhancements later, but if you have a highly corrosive environment, like near the ocean, this is the product you're going to go with because it's going to hold up. So again, kind of a cheat sheet here. Polyesters, again, they can really range from just okay to pretty darn good anymore. Some Ps are kind of in the middle. Your PVDF is your best. Price points, again, goes up as you move left to right. The warranty on the polyesters is a bit of a caution. There can be none up to a pretty decent warranty. So you got to be a little careful when talking about polyesters that you understand the specifics there. S&Ps are pretty long. PVDF is going to be the longest. And I do have the AMA specifications listed there that apply to each one of these. The 2605/621, which is now obsoleted, got wrapped into 2605, is the PVDF. That's your big time high performance product. So things to consider, again, not all polyesters are the same, huge range, a lot of variability in them. So proceed with caution. The differential between a high-end polyester and an S&P is now marginal in some cases, depending on formulation. PVDF is still going to offer the best UV resistance and the optimal exterior durability. Kynar 500 and Hylar 5000 are a trade name for PVDF. The paint companies must own a license to call their products by those names, and it must contain 70% of the resin. So of the entire resin or polymer composition, 70% has to be the PVDF. The other 30% is typically an acrylic kind of carrier vehicle to help dissolve the PVDF and then help with some cross-linking in the final film. Okay, I'll stop there for questions.
Okay, we have a lot of questions coming in. Let's see. Are structural colors like a butterfly being developed for accents or colors on panels?
Yeah, we'll talk about it a little bit. We'll hit it briefly. Decorative, or what we call print work or imagery work, we are seeing more and more of, and that technology is really advanced of late. You can now do digital printing. You can do flexographic printing. I'll show some examples here in a bit. But yeah, we are seeing kind of a move and a desire for that in the exterior space in the last few years.
Which coating is best to resist mold damage and easiest to clean?
It's a tough one. Yeah, kind of depends on your environment. The PVDF, we know, especially in white, there's something about the white pigmentation, titanium dioxide, that sometimes, I don't know if it promotes, but lends itself to some mold and fungus growth, especially in hot, humid areas. We don't see it out here in the Western United States hardly at all. Any of these paint systems are going to perform about the same when it comes to organic growth, but it really is a factor down around the Gulf and in the Hawaiian Islands as well. There are some paint systems out there that tout themselves as being more resistive to that kind of growth. I personally don't have a lot of experience with them, but there are cleaning techniques and some cleaning products that help as well. I can't get into those details here, but there are some solutions out there that help mitigate it. But yeah, it's a tough one if you live in an environment that's wet continuously. It can be problematic.
Okay, let's do one more question.
Okay.
What warranty time range is available for PVDF typically?
Okay, so again, it varies a bit by supplier and manufacturer, but I am seeing, I would say 30 is probably a good average. I see some that are still at 25. I see some that are up to 40 years. But it does vary depending on the paint supplier and then the panel manufacturer as well. And we'll talk more about warranties and how to read them at the end to give you a little bit more insight to how those work.
Okay, thank you for those questions. We'll take a few more in a little bit. And for now, we'll get back to the presentation.
Okay, so enhancement options, fun stuff. So spotlight question here. What important building considerations can influence the type of a pre-painted metal that gets specified? There's a lot, and this is just a few here. So proximity to salt water, it's a big one, especially out here on the West Coast, very corrosive. We're going to talk about that in detail. Building energy efficiency, we're going to talk about cool pigmentation, cool roof, some of the LEED and the Title 24 specs and Cool Roof Rating Council that are out there. Desired color, do you want something unusual or different? There's a lot of specialty pigmentation available. How visible is the roof surface and the reflection of it? Is it, when the sun hits it, are you blinding the poor folks that live across the street? Are you interfering with aircraft trying to see a landing strip, up above? Those are things we have to think about. The other materials you use with pre-painted material is important. We'll talk about those cautions. You got to be careful during installation that certain things are not touching or that you have the right barriers in place. Exposed eaves, unwashed, unsheltered areas. We'll get into that a bit. So the first one I talk about here is kind of like the look, aesthetic things, right? So micas and metallic pigments. These are the sparkly kind of, champagnes and silvers and golds that are out there. We see it probably more commonly on cars, metallic finishes on cars. These pigments are actually mostly micas now. We use the term metallic because back in the day, they used to be actual pieces of copper and actual pieces of aluminum to get that look. That's not the case anymore. They had durability issues, but that term is still around. Clear coats. We use clear coats for a couple different reasons. One, to give extra UV protection if we're worried about that. Extra corrosion protection. It can also help with graffiti resistance that we have listed here. Marine and industrial, again, corrosive environments, cool roof pigmentation, textures. We're seeing a new kind of interest in textures the last few years. And then prints and imagery, which someone brought up. So I've got a slide or two on that. So here we go. We add mica pigments to the paint to get this sparkly, shiny look. Like I said, historically metal flakes, but not so much anymore. We just still call them that. You get a kind of a light catching effect. You can also use pearlescent or color shifting pigmentation as well. Again, you see this more in cars, right? That look where as you walk around it, it might shift from purple to green or from green to blue. We can do that same pigmentation for metal panels on buildings. That's just not very common. Word of caution on micas. They are directional in nature. So the direction in which we paint them and they lay out on the strip matters. If you turn two panels opposite from each other, you will see a visual difference with the eye. We have some pictures here of what not to do. They're also batch sensitive. It's very hard to control exact color on the micas and metallics from batch to batch and run to run. So everything that's needed for a project needs to be run at one time out of one batch, one production run, or you could have slight shifts in the visual appearance. Stream environment enhancements. So we can modify these to get good durability for coastal or industrial environments, it usually involves adding more primer, what we call a high build primer, and also maybe adding a clear coat. So now we're talking about a 3, 4, or even 5 coat system as opposed to the traditional 2 coat system. But usually when you do this, you can get a warranty in a marine environment. It's going to be a little bit less than the standard warranty you would get, but it's still warrantable. My caution on that, though, is that the definition of marine and the definition of proximity to saltwater varies by supplier. So there's not one rule of thumb. Some suppliers say it's a mile. Other suppliers might say it's 1,000 feet. I like to tell everyone, look, if you're building something with pre-painted metal that's within a mile of salt water, you probably need to have a conversation with your supply chain up front and make sure that you're ordering the right product and that you're going to have a warranty. Unfortunately, I get a lot of warranty requests, and then we look at the location and find out that they did not use a marine paint system, and it's a marine location, and then we can't offer a warranty on it. And the owner was unaware of that. It's not a very fun discussion to have. Clear coats and graffiti. So, right, you can add a clear coat, again, for a couple of reasons. We used to see clear coats added for abrasion resistance in areas where there's a lot of blowing sand. I mean, we've done projects like the Middle East and stuff where sandstorms are an issue, but here in the US, it's usually just to provide a depth of look or to help with UV fade resistance. So we talked about pigmentation. If you want to use a color that needs a lot of organic pigments, you can do that. You can get your primary blues and greens and reds, but you're gonna have to put a clear coat over it to protect it out in the field. We run a lot of signage, logo signage like Pizza Hut red, Chevron red and blue. Those are very bright primary colors. They gotta have a clear coat over them. And then it also can bring UV. There are anti-graffiti or graffiti-resistant clear coats available as well. They do 2 things. One, it's very hard to get anything to stick to them. And then if something does stick to them, they clean up very, very well afterwards. Clear coats. We use the term clear. They're not completely clear. They have a very slight yellow tint to them. That's the UV blockers we talked about earlier that are in that clear coat to protect it. So on a lighter color, you might see when you apply that clear coat a very slight shift in the base color visually, but really only on the light colors. And what the picture here on the left is a standard primer, standard top coats. The middle panel has got some high build primer on it, but no clear coat. And then on the right, we've got high build primer and clear coat, so a full marine system. Just to demonstrate that on the darker color, this red here, you don't really see any change in how it looks. But on the white, you can see a little bit of shift. So we just like to warn people. This can be compensated for. I mean, you can reformulate the color coat to counteract that yellowness if it's objectionable, but usually people, if everything looks the same, no one seems to care too much. It's minor. Backers. We talked about backers earlier a little bit, and it's kind of an overlooked item. People always ask, well, I don't want to pay to put paint on the backside because no one's going to see it. And we go, well, that's great, except you'll have issues. So, it's usually a neutral color, but it is consistent. It is controlled for film and color, just like everything else. You get overhangs or eaves inside engineered metal buildings. You're going to see that backside, so you want it to look decent. But again, we can do full coat on both sides if need be. It does help with corrosion protection, and it helps with transportation. Again, not only in coil form, but in panel form, so you don't have bare metal rubbing against the painted surface. Cool colors. Cool colors were introduced back in the early 2000s. So these are pigments, special infrared reflective pigments. Some very smart people came up with a way to chemically and physically alter inorganic pigmentation to reflect IR wavelengths, which is where you get heat generation on a surface from. So this allows us to do darker colors that act more like a light color when it comes to getting hot and building up temperature. Any paint system can have these pigments added to them. doesn't matter. It has become pretty much the norm in the coil coating world. Almost all paint systems, especially the PVDF kind of R500 paints anymore, are just automatically formulated as cool pigmentation, whether it's asked for or not. Does a very good job of minimizing heat buildup, reducing cooling costs in hot climates. And we've got, yeah, some more on it here. So it gets a little confusing, the nomenclature, right? So we use solar reflectance, emissivity, and solar reflective index are the terms that you will see in specifications and in the business around cool paint systems. Solar reflectance is the amount of solar radiation reflected off the surface. It's usually expressed as a percentage or a decimal plate, 1 to 100 or 0 to 100. Emissivity is the amount of heat a surface dissipates away from itself. How does it shed that heat? Solar reflective index, or SRI value, is a very long, kind of nasty calculation, taking those top two values, putting it in, spitting out a number. This is monitored and reviewed by the Cool Roof Rating Council. You can list your product as third-party certified. You have initial results, you have aged results, because you don't want to lose these properties as the product ages out in the field, right? And that's one advantage pre-painted metal has. The SRI values for pre-painted metal tend to not move at all over time, and sometimes they actually improve because we just have hardly any fade or color change over time. Got an example here of what kind of a color palette, color chart might look like from panel manufacturers these days. They almost always list their SRI value or their solar reflectance value on those colors now. And obviously, matte black, not made with cool pigmentation, is still problematic, but you can get a black that that qualifies as cool, depending on your definition. That is possible. So here's a lot of you are probably much more familiar with LEED than I am. I know enough to be dangerous, but 4.1 for low slope, it needs to have an initial SRI value of 82. Those are whites, right? We can't get to 80 plus or even 75 plus SRI with anything but whites. So low slope is white. Steep slope, however, at 39 initial SRI, there's quite a few mid-tone colors that will meet that without an issue. Talk about gloss and sheen, and this gets a little confusing with reflectance sometimes. Gloss and sheen is how we describe the visible shine off of the surface. We measure it at either 60-degree angle, viewing angle, or 85. 60 degree is gloss, 85 is sheen. High gloss, high sheen is a very high glare or shiny surface. Whereas you go to low gloss, low sheen, you're going to have a very matte appearance. And we are seeing a trend to this, especially in residential, right? No one wants a very shiny, glary roof in your neighborhood or next door to you. So we're seeing movement to low gloss, low sheen, or a fully matte finish that doesn't have any kind of reflection on it. This is different than light reflectance value, which is, right, the amount of light, it's kind of how light dark it is. So we've got an example here of how all these factors are kind of different from each other, and they're independent of the cool properties we just talked about. You can have a low gloss, low sheen matte product that's also a cool roof with very high solar reflectance. So here's an example. This is right, the glare. It's been spec'd around airports for a long time. We're seeing it more. HOAs and stuff don't like to have glary metal roofs in their neighborhoods. We can kill the gloss or the sheen on a product a couple different ways. We can use flattening agents. We can do textured finishes. So now you're breaking up that light reflectance and that textured surface. And we do have ultra matte finishes available. The gray samples there, the top photo, those are numerically the exact same color. The panel on the left, though, is in a matte micro texture, whereas the panel on the right is a traditional kind of mid-range gloss sheen product. That is what reducing gloss does to the physical appearance of the panel. Then we've got a black down here as well, kind of showing how SRI value there at the end, that 25 and 29 value, are really independent of what's happening with the gloss and the sheen on the product. They're not connected. I do see some architects and specifications. I've seen some city and county specs where they get these values confused and aren't really understanding what they're asking for. So be careful with those. Here's our imagery that someone asked about. I don't have a picture of a butterfly or anything fun like an animal, but we can do these kind of variegated looks on our coil lines. So we can do print rolling, put a base color down, and then you come back once or twice with some other colors with a special roll that's been laser etched to give you a particular look or pattern. You can do this pretty quickly. We run a lot of these days. And they are done in the same high-end paint systems we just talked about. So their performance is quite good. Their warranty is going to be very similar. Imagery, true imagery, is done a couple different ways. Laminates. So this is a film that's been printed with an image that's then laminated or glued to the metal substrate. You get away from repeatability, right? You can do all kinds of unique imagery. You can make it look however you want. Long-term durability on these is not as good as traditional coil-coated product. See these more for interior applications, not so much for, or garage doors, not so much for roofing and wall. But digital printing, this has made huge strides recently. It's like a giant laser printer, but for one of these coil lines. And they are using high-end paints to do it as an ink. And you can do large-scale versions of imagery with a better system. So that just came online in the last few years, and they're still working out a few of the kinks on it, but it's out there. There's several lines doing it. Okay, any questions on that? I know that's a lot.
Yes, we have a few questions here. Who sets the coating measurement spec? Coating supplier, customer, or manufacturer?
No easy answer. It can be all three. The basic specs are almost always set by the paint supplier. So the paint supplier will tell someone like myself, who's the coater, the applicator, what that paint needs to be run at as far as specifications. However, they've often developed those specifications in partnership with the end user based on what they need for their product. But for the day in, day out, I want to say run of the mill or just your standard products, those specs are set by the paint supplier and then handed down to the rest of us. But there is customization that goes on as well between all parties involved in the supply chain.
Does the backer coat have the same life as the top coat?
Typically, no. A standard backer is typically applied at half the film thickness, so it's not going to have the performance. But it's also usually not exposed. However, if it is going to be exposed and you're concerned about performance, it can be run at a full film, or you can upgrade it to a better technology. That's totally doable. So I can speak for Steelscape. The backer we run is a high-end warranted polyester that we just run at a reduced film thickness. If we ran it at a full film thickness, it could get a warranty like the stuff on the top side. So there's a lot of options there. It can be just as robust as the top side if you want it to be.
Okay, let's do one more question. What can you do to restore a metal roof where the color has begun fading or chalking?
Yeah, it's a tough one. Really, your only option if it's severe is you can do a field paint. You can buy some pretty good air dry. There's actually air dry PVDF, air dry Kynar available. And you can repaint it. You can prep it and repaint it and get probably another 10 or 15 years out of it if it's done right. There's kind of just a handful of top level contractors that do that. But otherwise, once that chalking and fading has started, there's not much else you can do other than coat over it.
Okay, we will take a few more questions at the end of the presentation, but back to you, Michelle.
Yep. I got 11 minutes. Okay, now we're going to talk about durability issues and warranty coverages in a bit more detail. So what are the three elements warranted for pre-painted metal products typically? The the corrosion performance of the substrate, if it's an aluminum zinc product, film integrity, and then the shock and fade. That's usually what's going to be in your warranty. But again, they can be anywhere from 5 years up to 40 years. I think there's a couple of 50-year film integrity warranties out there now. But they're usually going to cover excessive chalking, excessive color fade, and delamination of the top coat of the primer to the substrate. So paint peeling off, right? That's kind of a big deal. We want the paint to stick. Failures for any of these can be due to a lot of things. There's a lot of root causes why something might not hold up for its warranty term. It could be improper application or installation. It could have been a bad paint formula, poor coater quality control. It could be environmental conditions that have impacted it. And there's a significant difference between the paint system types as to warranty coverage. This is an old slide. I probably need to update it with something else, but this company in Japan, Taiyo Steel, way back when in the 80s, installed this whole big side of their building, all in the same color match color, but with different paint technology. So they did Kynar 500 acrylic polyester, another section of Kynar, and then the silicone modified polyester. I'm not going to talk about acrylics because no one runs those anymore. But 14 years later, you can see how the Kynar really hasn't changed and looks quite good. Whereas the polyester and the silicone polyester has faded quite a bit. My only caveat to that, like I said earlier, is polyester and silicone polyester technology has come a long, long way since 1981. You would not see this kind of differential anymore, but you would see a difference if you were to put Kynar 500 and a polyester and a silicone polyester out together, same original starting color, over time, but now I'm talking like 20, 25, maybe even 30 years, you are going to see a fade difference between them. They will not be the same. Excessive chalking. This is one most people aren't all that familiar with, and it's just what it sounds like is you get this white chalky residue on the surface. You can run your hand on it. It comes off on your hand. This is degradation of the resin or polymer system, usually by UV attack. So that long polymer chain is breaking down into little smaller sections. And remember, it's got the pigment attached to it. And now it can just come off the surface. It's not tied up in that film anymore. High-end paint systems like the PVDFs are going to offer warranties of 20 years and higher against chalking. Same with S&Ps. There is an ASTM method for measuring the degree of chalking. It's a scale of 0 to 10. The higher the number, the better. So a 10 means you don't have any chalking. An 8 means you have very, very little chalking, and so on. It's a bit of a subjective test. I have not seen a chalking claim in many, many years. This is not something we see too often anymore out in the field. It's pretty rare. Color fade, however, this is a big one, right? This is probably that and your paint sticking long term, but color fade is a big deal. Of course, fading's caused when the pigments are attacked by UV and start to lose their color. We measure it by delta E. Again, that's a numerical value that represents the total color change from where it started to where it is now. Human eye doesn't start to see that until you get to 0.5, maybe up to 1 delta E and beyond. PVDF systems, warranties allow for the smallest amount of color change. So the warranties are not saying that there won't be any color change. It's saying you won't have color change beyond a certain delta E value. And these are actual color cards I have here, the blue and the red here, that shows starting color at the top, a delta E of 5 units in the middle, and then a delta E of 7 units at the end. So you can kind of visually see, right? If the warranty says will not fade more than a delta E of 5 units in 20 years, they're saying that you might have some color fade between these top two, but no more than that in that time period. And what we find, most people, if your roof is fading evenly, after 20 or 30 years, no one really notices, right? When we get color fade complaints, it's usually because part of the roof looks better than the other. And I got a picture here. We call these candy cane striped roofs. This can happen for a couple of reasons. It could have been that someone mixed 2 different paint systems on a roof. We see that quite a bit. Could be that the film thickness was different on those panels. It could even be different paint suppliers. You cannot mix, supplier A's PVDF and supplier B's PVDF may not color fade exactly the same, even if they're called the same color to begin with. So can't mix suppliers, can't mix paint types. Delamination or lack of film integrity. This is a tough one. These are the hardest warranty claims that we deal with because you just don't always know the root cause. Usually happens after the product's been installed for a long period of time. It can present as just the top coat coming off the primer. It can present as the whole paint system coming off the metal. Can be bubbling, peeling, chipping, cracking. There's a lot of different ways it presents. There's actually about 500 root causes for it. I've listed the most common ones we see, which is low film. That's a coater application issue. Bad pre-treatment, you'll get loss of adhesion to the metal. Inadequate or extended cure time. So when we cure and dry these paints on the line, if we overbake it or underbake it, you might have film integrity issues out in the field. An incompatibility between your top coat and your primer can result in this. The biggest one is mechanical damage. Scratches that have occurred, damage that have occurred, you get an opening in the paint system. Now you have a spot where water, ice, other things can get in there and start peeling that paint away. The example I have here, I don't know if you can notice, there is a very distinct vertical line where each of this peeling is starting from. And what this most likely was when they installed this building, dragging the corner of another panel up that panel and leaving that scratch. And then over time, that's just an opening where the paint can come apart. Other failures that we need to avoid, this is using other materials and metals. So dissimilar metals or galvanic corrosion. There's whole hour-long presentations on that we could get into. You got to be really careful in corrosive environments around the marine locations, salt water, not mixing wrong metals together, or you'll get this kind of a corrosion occurring. This is stainless steel fasteners with a painted galvalume substrate. You have galvanic, this is about 300 feet off the surf break outside of San Diego, so highly corrosive environment. The galvalume panel is sacrificing itself to protect the stainless steel fasteners. That's what's happening there. Sealants, gotta pick the right sealants. Swarf or metal filings after drilling, cutting, sawing on a job site that get left on the surface will start to rust. People call and say, my panels are brand new, they're rusting. I go out and look at it, I go, nope, your panels aren't rusting. The debris from the sawing that took place that's on your paint system is rusting. So you got to do good cleanup. Wet stack, that is corrosion that can occur when the panels are in bundle form on a job site before they're installed. There are lots and lots of technical bulletins and white papers around all of these things to educate installers and contractors on how to manage these things and minimize it. Oil canning, not a failure, not warrantable, but something that needs to be understood in light gauge metal. Standing seam roast, right? Is that buckling or wave effect you can get. Dissimilar metals. Dig in a little bit more. This is a stainless steel canister recessed through a painted galvalume overhang. So again, more active, less active. The further away these metals are from each other and in a corrosive environment, the more likely you're going to have this phenomenon. So the metal is corroding underneath the paint. That causes the paint to lose adherence and it bubbles off. This comes in as my paint is failing claim. It's not the paint, it's galvanic corrosion. Proximity to the ocean is a big deal. And so you just have to have either a barrier in there so they're not in direct contact, or you need to use something other than stainless steel. You cannot put the aluminum zinc substrate in direct contact with wet concrete mixtures. You got to have a water vapor. Otherwise, this is a concrete wall on the right, metal panels on the left. They did not put a vapor or a water barrier in there, and it's causing the paint to peel off the metal panels due to the moisture content from the concrete. Chemically treated wood is an issue too, because they usually use copper compounds, which is incompatible. If that can leach out and get on the painted metal, you will start to see corrosion. So this is a house in Hawaii. This deck used treated wood. The water running off that deck onto the metal panels, the roof line below it, was causing corrosion. As soon as you got out past the deck, the panels were fine. Here's our swarf and metal filings, again, from cutting, friction saws. And we know this has to happen at job sites, but you got to clean up. As long as you clean up all those filings and get them off the surface right away, you're going to be fine. But it is mistaken as early degradation of the panel itself. This picture on the bottom is the worst case I've ever seen. Like, I don't know what they were doing at this job site, but that is a lot of metal filings and debris left over. Again, we have technical bulletins on the proper cutting techniques and blades to use and how to clean up. Once this red stain here that you see at the top stains the paint surface, it's really hard to get it off. So long term, this is going to perform fine, but it looks unsightly. So it's much more of an aesthetic issue than a performance issue. Wet stack. This is oxidation that occurs during transport or storage when panels are in tight contact with each other and there's not good airflow. Moisture can penetrate through the paint system down to the substrate and start corroding it. You get this little tiny blistering or textured effect on the paint system, which will eventually come off and flake off. So yeah, there's a whole paper on how to properly store product at a job site. Anyone needs some late night reading. Oil canning. Again, not a paint failure, not a warranty issue, just something we like to bring to everyone's attention. So this is this buckling pattern you see. It can be due to shape in the panels incoming. It could be due to the substrate underneath as well. It's not always one root cause. Long panels, 20 feet plus long spans of architectural panel are going to have some buckling just about no matter what you do. It's almost impossible to get rid of it. We recommend styrations or pencil ribs. So this is on the exact same roof, panels without the styrations and panels with the styrations. And you can see that you get rid of all that buckling and waviness by doing that. Low gloss coatings too, the matte finishes hides a multitude of sins. You don't get that reflection off the surface. And I know we're a minute over, sorry folks. How to avoid failure. So we don't want a warranty failure, right? So we're going to specify the right paint system for the application. You're going to use a reputable coil coater, not going to mix batches. Reputable product manufacturer of the panels themselves. You use a good installer that knows how to handle and work with this product and get it up successfully and installed successfully. And then there is maintenance. They do need to be cleaned or washed off. One great thing about pre-painted metal, very easy to wash down, hose down, brush down. That is written into almost all of the specs. So the details of the warranties. Please do not get hung up on the title. The title of a warranty may be 40-year paint warranty, 30-year paint warranty. Okay, but for what? You got to read in how much color fade is going to be allowed in that 30 years. How much chalking is going to be allowed. I've seen some warranties where the headline is 40 years. When you read in, the 40 years is only for film integrity. The chalk and fade is something less. So they're boring. No one likes reading warranties, but make sure you read them thoroughly and you understand. This is kind of a representation here of how they will say, look, the film integrity is this. The color fade will be a delta E of less than some value for the period, whatever the period of time is. Chalking will be better than an 8 or a 10 or whatever they've decided on. You do see differences between wall and roof applications sometimes. They will make a distinction, whether it's a vertical or horizontal installation as well. So those are the details that need to be looked at. Don't get hung up in the big number in the title of the warranty. So I think I covered all that. And marine, good, marine, especially on the West Coast, needs to be discussed ahead of time and approved ahead of time by the supply chain. Do not assume if you're near the ocean that you're going to get a warranty without talking to someone first. Okay, I know I went a little over, sorry. Questions?
Okay, thank you, Michelle. Let's do one last question.
Okay.
How much does compass directional orientation have to do with color fade and chalking when the roof is viewed from above over time?
Yeah, you will, depending on the color and the location, see more fade typically on the southern or western elevations. But that also is dependent on actual elevation above sea level too, right? It's gonna be more pronounced the higher up in elevation you go. So high elevation, high UV, you'll see more of that differential fade, depending on compass direction than you would at kind of standard elevations and locations. And the color, right? Darker colors are probably going to show it more. Paint system too. Your PVDF would be the best choice to avoid that. You'll get more even, consistent color fade regardless of compass direction.
Okay, we have another one that just snuck in, so let's answer this one. Can you please explain capillary action?
Capillary action, yeah. So
Capillary action.
Yeah, that's wet storage. So when you get really, really tiny, it's usually vapor, moisture vapor, that works its way. Now, these coatings are meant to be semi-permeable, so moisture can come in and out of them. But if you don't have any airflow between the panels or in a coil form, and you get moisture in there, it works its way down to the surface of the substrate and starts it forms zinc hydroxide on the metallic coating layer, which kind of a powdery white substance, and then it starts to push the paint up. So you get those capillaries just, right, it just sucks it in. So it wicks in, like even on the side of a coil that's wrapped up, and those wraps are tight, but you'll get water that pulls in into the side. It may go in for several inches to the edge of the coil and cause damage. That's capillary action. It's like a water drop hanging right on the lip of your cup or the side of a bowl. It's capillary action, but it can happen in these panels. It can happen in coil form. They got to stay dry or be exposed to air. Make sure it doesn't cause issues.
Okay, I'm going to throw one last one at you. What about resistance to hail damage?
Good one. Most of these paint systems are fairly robust. It takes quite a bit of hail, kind of substantial size hail, and I can't give you specifics, but they will hold up. Now, you might get a dent, right? You might get a dent or an impression from the hail, but it won't necessarily crack the paint system unless it's pretty bad. So now you're just dealing with a product that doesn't look anymore because it's got hail dents on it. Hail resistance, however, and there's all the ratings out there, I'm sure a lot of you are familiar with, is actually more around the structural integrity of the panel and not the paint system. So that hail rating is based on how the panel is designed and its resistance to denting from hail. Yeah, I do quite a few insurance letters per year being asked to assess whether a warranty is now void because of the damage from hail. If it doesn't crack through the paint system, it should be fine. But yeah, that is a problem in certain parts of the United States, unfortunately.
Okay, thank you, Michelle, and thanks to everyone who joined us today. That's all the time we have. If you need to reach out with any additional questions, our presenters' contact information should be up on the screen momentarily. Just a reminder before everyone leaves, if you would like to re-watch today's presentation or share it with a colleague, we'll be emailing the link to the recording to everyone who registered for the webinar within a week. Also, it may take up to 5 business days if you are requiring a certificate, so keep an eye out on your inbox and don't forget to check your spam or junk folders. Finally, after you shut down Zoom, you'll be taken to a survey to provide feedback on your experience today. Please take a moment to complete the survey as it helps us to continue to serve your needs in the future. Thanks again, everyone. Thanks, Michelle, and have a great day.
Thank you. Have a great day.